performance future with predictive analytics. Before we begin today's presentation, there are a few housekeeping items that I'd like to address. The slide area can be maximized by clicking on the Maximize icon in the top right corner or by dragging the bottom right corner of the slide area. To ensure an optimal viewing experience, please ensure that you have checked system requirements along with bandwidth considerations. If you have any technical difficulties, please click on the Help link located via the question mark widget at the bottom left of your screen, where you will find details about system requirements and frequently asked questions. To ask questions during today's presentation, please type your questions into the Q&A widget and hit Submit. We'll answer as many questions as time allows. Also, notice the Learn More widget. Here, we've added a copy of today's slide presentation, a link to ConicIT's website, as well as must-read white paper published by Forrester, Digital Transformation Needs Mainframe DevOps. We also encourage everyone to fill out our survey before the end of today's presentation, and by submitting your response, you will automatically be entered to win a $50 American Express gift card. Once again, if you have any technical difficulties during today's presentation, please try refreshing your screen or click on the Help link located via the question mark widget at the bottom of your screen, where you will find details about system requirements and frequently asked questions. We are extremely pleased to have as our speakers today ConicIT Vice President of Product Management, Jacob Ukelson, and Compuware's Product Manager, Spencer Hallman. With that, I'd now like to welcome and hand things over to Spencer.
Thanks, Janet. So at Compuware, we are mainstreaming the mainframe, and the way that we're doing that is bringing DevOps to the mainframe. And your distributed groups are probably already doing DevOps today, and they're using tools to do this. They're using Jira and Jenkins and SonarSource and Zebia Labs, Corelog, Splunk, AppDynamics, Dynatrace, BMC. And we're taking our mainframe tools and we're integrating them in with the same tools that your distributed teams are already using. So the mainframe then just becomes another part of your DevOps cycle. And today we're going to talk about how we're integrating with ConicIT to do a little bit more on the ops side. And for that, I'm going to pass it over to Jacob to talk about what is ConicIT.
Thank you. Hi. So what is ConicIT? The idea behind ConicIT is to provide essentially an automated way to look at what's going on from a performance perspective at your mainframe applications. So the easiest way to think about it is sort of a robot that has intelligence that's watching the existing monitors that you have that are monitoring what's going on your mainframe at the application layer, and understanding that and trying to find whether or not the behavior of your mainframe is normal. So it acts sort of like a human. What it does is it learns the normal behavior of your mainframe and then tries to find anomalies. And when it detects an anomaly, it makes sure that the anomaly is important enough, again, based on what it's learned, and then sends an alert as appropriate. So another way to think about it, sort of trying to map it back to the existing technologies, is essentially it's a way to set an infinite number of dynamic thresholds that are learned specifically from your installation. So it's not static thresholds, which cause lots of problems, but essentially it's learned dynamic thresholds that's continuously going on, paying attention to what's going on in your mainframe environment, and using that to create thresholds for every minute, second, hour, and continually learning that and changing them as your workload changes. Once it finds an anomaly and it gives you an alert, it also points you to essentially the subsystem that caused the alert, that caused the problem, or where the anomaly happened. And that is makes it very easy to find where is the root cause, because if you actually can see where the anomaly happened, when it happened, then you can very easily understand what needs to be fixed. And so the idea is that you have a single screen where you'll be able to understand what's going on from a performance perspective, the behavior of your mainframe, where there are anomalies, and then find the root cause if there is a problem. And I'll hand it back to Spencer to talk about Strobe.
Thanks, Jacob. So Strobe is a, oops. So Strobe is a part of, hold on, we're having a little difficulties here. So Strobe is a low-density sampling tool that is going to provide you with a deep dive analysis. So ConicIT is going to identify that there is a situation occurring, and what Strobe is going to do is do a deep dive into where the problem is occurring to give you the information that you need to act on. And what do we support? We support all the major subsystems on the mainframe: DB2, CICS, IMS, MQ, IDMS, database, as well as support most languages that execute up there as well: COBOL, PL1, C, C++, as well as others. Our measurements can be on demand or scheduled or upon the next execution, and we do have APIs which ConicIT takes advantage of to kick off these measurements. So when the measurement is completed, a profile is created, and that can be analyzed in iStrobe, which is where you would do your analysis via a browser. So there's little to no green screen really needed for this. And then another piece of Strobe is Strobe Insight, which allows you to run actionable analytics across all your Strobe profiles, as well as SMF data to identify activities that a Strobe measurement would not necessarily have caught earlier. Oops.
Okay, so DevOps for the mainframe. I'm sure most people have heard something about DevOps, especially in the distributed environment. And one question that comes to mind is essentially, does it matter for the mainframe? Why does it matter for the mainframe, and what you can do about it? Well, the answer is it does matter for the mainframe. And one reason that it's really starting to matter a lot more for companies that have mainframes is the notion of digitalization. And the notion of digitalization is trying to take digital technologies and use them to change business models, change business processes, and essentially change the way you do business. And since the way many companies do business is very dependent on their mainframe. In other words, their business processes exist on the mainframe sometimes. Their data almost always exists on the mainframe. And they'll need to make use of both of those, both business processes and data, and change the way they use them. So therefore, the notion of being able to do that very quickly and being able to do it essentially in a way that doesn't disrupt what's going on and get used to changing it much more often than ever before, that is why DevOps is becoming more and more important for the mainframe, because the idea behind DevOps is essentially a way to allow you to do iteration quickly at an application layer. And if you think about what's going on in a DevOps or an organization that's adopting DevOps, and this could be true both for the distributed side or for the mainframe side, it's essentially the ability to take an application and iterate around it as quickly as possible. And these are based on many theories that existed for a long time. You know, for example, the quality cycle, where you do, check, act, and plan. And the idea is to enable organizations to do that as quickly as possible. When they're doing this in a distributed environment, they're using agile development techniques, and then they're using DevOps to be able to deliver the results or the features or the new products as quickly as possible. Well, the same is starting to happen in the mainframe environment, where organizations are starting to understand that they need to be able to deliver more from the application perspective from the mainframe as well. So they're starting to adopt these techniques of trying to do certain things agile, trying to be a lot faster in doing their delivery. And if you want to be fast and you want to do it quick, and you want to be able to have a cadence of change that's higher than it exists today, then you have to be really good at making sure the quality of what you deliver is very high. Because if you're delivering more and the quality is poor, well, essentially the velocity will just cause an issue and cause you to slow down. And so if we think about what was going on traditionally in the mainframe was always up here in the low velocity, high quality quadrant. I mean, anyone who is in the low velocity, low quality quadrant, well, it doesn't really matter. They shouldn't be around anymore. But mainframes have done a very well in the low velocity but deliver very high quality. And this was fine before digitalization. But now what's happening is mainframes are being asked to essentially increase their velocity, but of course we really can't allow quality to suffer because of the fact that the mainframe does manage business processes, does manage critical data. It really can't suffer on the quality side. And that's what everyone's worried about when they're thinking about digitalization and adopting DevOps on the mainframe. They're worried about this guy over here. I understand it's kind of hard to read his T-shirt, but essentially it says, I don't test very often, but when I do, it's in production. That's not how we do things in the mainframe. We want to make sure that we can have both the velocity and the quality. And so that's where we want to get up here in this upper right-hand quadrant. And in order to be able to do that, we need to make sure that we get feedback from production that is fast, to the point, and actionable, so that if there is an issue that does show up, then we can address it and fix it as quickly as possible. And so, okay, how do you do that? And so at ConicIT, we spend a lot of time on the mainframe, looking at the way people actually use their mainframes, monitor it, and manage that. And what we've understood is that by being able to do behavioral analysis, in other words, doing the kinds of things that a really good operator would do, which is essentially watching your machines and understanding what is normal. Anyone who's ever gone and looked at the way really good operations folks work, they essentially understand what's going on in their environment. They can look at a screen and they can look at the results of a monitor if they are looking at the right place and they focused on the right thing and they happen to be around at that time. They can very easily understand what is anomalous. In other words, they can very easily understand that the system, the application, is not working as normal. And so since we can't have really wonderful operators watching everything all the time, first of all, because many operators are retiring, and it's going to take a while to build up the level of expertise and skills that exist in the mainframe as these people retire. But not only that, even if you have really great people, they can't be watching everything all the time. And so what you need is essentially an always vigilant system that's watching what's going on, understands what is normal for your machine or for your system or for your application, and then apply predictive analytics to understand, based on those anomalies, when you're going to be having a problem and the kind of problem you're going to be having. And that's the gist of, again, what's behind ConicIT. It's essentially an ever-vigilant system that's watching it using deep mathematical algorithms and making sure that your system is performing normally at all times, and when it doesn't, to inform people about, create an alert and inform people about the issue, and also give you the background, essentially the deeper information about what's going on so that you can fix it as quickly as possible. So what does predictive analytics mean, and how do you leverage behavioral analysis? Well, one way to go about this, and we've seen some companies that try this, is a purely statistical approach, which is essentially to take a mathematical or statistical system like SAS or SPSS or whatever you happen to use, right, and pick out some algorithms from that, standard algorithms that are used for lots of different things, and try to apply it to your data. In other words, monitors exist. They gather great data. We use them as well. We don't have a monitor. We leverage your existing monitors. And what many people try to do, just try to apply standard algorithms to that to understand what's going on. So the idea is that you can then predict what's going on. The good news is that will always work, right? Just take data, put it into a generic predictive analyzer, essentially different models or different out-of-the-box algorithms that exist. The bad news is it doesn't really do anything useful. So it's easy to do, but it doesn't do anything useful. What you really need in order to be able to do this is something that understands the domain that you're trying to watch. If you don't understand the domain, you really can't predict or understand behavior. So it needs to know certain things. It needs to know things about computers. It needs to know things about performance. And the model needs to know things about mainframes. And so the idea is that you need to be able to understand what's going on in the domain, and the algorithms need to understand what's going on in the domain that is gathering information for. Because if you don't do that, then essentially the system won't provide any useful feedback. And the example I always give people, which is essentially, if anyone could take just a generic set of algorithms and assume they can use that to predict anything, well, then you can use that to predict the stock market, and I wouldn't be doing that. I'd be rich. I'd be going there. So essentially, ConicIT has spent years understanding the mainframe and tuning the algorithms and building a model that is mainframe-specific and performance-specific in order to understand and provide the predictive analytics. And just an example of context, what I mean by that is that if you just gather data, and here's an example of data that's gathered from a mainframe. This is actual production data from a mainframe. It's this nice kind of chart, but doesn't really mean anything. I couldn't use it to predict. I can't use it to analyze behavior because there's no context involved. It's just a bunch of dots. I can just assume maybe the bunch of dots will continue as they were before, not sure exactly how, but that doesn't really help me very much. But once I have context, once I understand what's going on, and I know that this is periodic data, this is data that's recurring over a week, then all of a sudden the model can start trying to understand this and understand, oh, okay, Sunday works this way, Monday works that way in a production environment, and perhaps there's going to be repeat. Maybe Mondays are more similar to another Monday than a Monday is similar to a Tuesday. And so being able to provide and understand the context makes all the difference in being able to build a model that's useful as opposed to a generic model that's not. And so what we do at ConicIT is essentially we allow you to gather these variables from your existing monitors, either as single variables or combine them in different ways. And we have out-of-the-box ways that we recommend to gather information, or you can be looking at other things that you think are important to your organization and your environment. It has a definition of anomalies, of time-related anomalies. It has work-related anomalies. In other words, it understands the idea of what an anomaly on a mainframe from a performance perspective is. And then it essentially builds up internally. It doesn't show it does show them, but it's not showing them as, we'll see in a second, so it's not showing them as thresholds. But essentially these dynamic thresholds essentially saying for every second of every minute, every hour of every day, this is what we expect your machine to be doing from a performance perspective for this specific application, for this specific combination of variables or this specific variable. And then ConicIT makes a decision. It says, well, I really don't need to do anything. Or it can decide, well, I really should gather more data because this looks like it might be a brewing problem. I better gather more data and aggregate it to understand whether or not it's really becoming a problem. Or I can alert. I can decide that this is an important enough problem and I need to alert someone of it. So the idea is that we have these detailed behavioral profiles built into the system, and we augment them by learning your specific system. So in other words, we have built-in intelligence into our system that understands, but it needs to understand your specific application, your specific parameters, and your specific system, and it does this over time. So it spends time watching your system, gathering information so that it can learn and understand how to perform. And if you look at the graph that we're seeing here, what we're seeing is essentially an example of what I call these dynamic thresholds. They don't show up here as a threshold. It shows up as these green highway, where essentially for this specific parameter, this is the green highway that ConicIT has built for that parameter. And if you look at it before this point, right before the edge here, then essentially what you're seeing is the past. This graph shows what happened. Beyond that, it's actually a prediction of the future. This is what ConicIT expects to happen with this variable over time, or this set of variables over time. And essentially, that is its prediction at the moment of what would be normal for this parameter. And so when you have an overage like in this chart, and just to make sure that people understand, sometimes being under from a parameter's perspective is just as bad or even worse than being over. For example, if you have a CPU that's over 80%, that may be fine on a mainframe. But you may have an application or a set of transactions that are below 20% utilization, CPU utilization. And that could be very bad because that could be starvation that has happened upstream. And so You have to be able to pay attention to thresholds that are above what you expect and below what you expect. And here's an example. This happens to be above what expect. And there's two anomalies here, right? We made this prediction, which is a green highway, and the system has gone above it in 2 instances. And the question is, what should the system do? And so ConicIT would gather this information from your existing monitors and then make the decision on what it should do. And, for example, should it alert? Or should it alert here? Or should it alert there? And what happened is because of the actual parameter that it's following and the actual graph that it's described and essentially what's going on from a mathematical perspective, it decides to give an alert on the first occurrence of the anomaly. But it doesn't give an alert on the second. And we can give lots of reasons why this happened, essentially because it's very peaky. It didn't happen for a very long time, and it dissipated very quickly. Therefore, there was no need to give an alert. And giving an alert on time before having the actual problem happen is invaluable, because what you'll see, as you see here, is that's what makes it actionable. I know essentially what parameters cause it, where the anomaly happened, what the subsystem that's driving it, what the application and transactions that caused it are, and I can use that to very quickly understand where the problem is. And because I see it at the moment of the anomaly and not later, I'm actually seeing the actual root cause. I'm not seeing everything that builds up over time. So, for example, if a queue is locked, if you look at it a little bit later, what you'll see is essentially things not being processed. You may see the CPU going to overage, but that's not really the problem. The problem was the original problem that a queue was locked. And so being able to understand the anomaly when it happened allows you to make it actionable and very quickly understand the root cause. And I'll hand it back to Spencer.
Thank you, Jacob. So when ConicIT alerts, it has the ability to kick off a Strobe measurement request, in this case into the CICS region. And so you saw that the CICS region, one of the things was that the QR TCB was exceeding a threshold of 88, and it was at 88%. So when we do that deep dive into the application domain, into that CICS region, we're looking at the profile within iStrobe. And to kind of blow it up a little bit for you, when we take a look at that transaction, we can see how it's affecting it. The fact that we're having problems with the quasi-reentrant or the QR_TCB, which is basically CICS is holding up these transactions. And how is that affecting this transaction? Well, on average, the transactions are being delayed for about 0.37 seconds every time. So if we can go back, or we can get into the CICS region and we can remove that barrier, the quasi-reentrant barrier, and there's some things I think the CICS system programmers might be able to do for that, then we can expect these transactions then to finish quicker.
So essentially, by combining these two systems together, ConicIT with Compuware, we've created what we call a production assurance system of intelligence. And the idea is that we have something that learns your system automatically. It essentially knows what is normal behavior for your system. It finds anomalies. It looks and continuously analyzes different parameters to be able to find anomalies. Once it finds the anomaly, this is way before the problem actually happens, and that's important to understand, right? The anomaly usually or almost always happens way before users are effective. So you're essentially being able to predict the fact that your users are going to be affected by virtue of the information that you've received by having this anomaly. We can then kick off a deep dive analysis through Strobe and use that to essentially gather information at the time of the problem, which is way before users are actually affected, and also way before essentially you're seeing all the side effects build up. And so being able to do this allows you to catch problems earlier, understand the root problems much quicker, and of course it also allows people with a lower level of expertise build up their expertise because the system is helping them. It's helping them to understand what is normal behavior by defining it through that graph, understand whether or not an anomaly is important by showing them what it decides to do, where it is, and where it alerts, and then helping them gather the deep dive information that's needed so that they can actually allow people to, or allow whoever needs to, or the system programmers, whoever happens to be working on this problem, to solve the problem as quickly as possible. So by combining these things, this artificial intelligence or this intelligence system essentially closes the loop to allow information to flow back from what's happening in production back to dev so that they can very quickly solve the problem. And so if we look at the stack that we use in order to make this happen is essentially, I'm going to start after development that uses Topaz to help them understand programs in general. But by having a runtime anomaly detection by ConicIT connected to your existing monitors, and again, as I said earlier, we use information at ConicIT from your existing monitor. You don't need to use a different monitor. We don't provide a monitor. We assume that every good mainframe shop has a number of monitors, and we can connect into all of them. And so we can also connect into multiple monitors at one time, gathering information from, as I said, different parameters, different LPARs, different subsystems. We can gather all that, combine it together to give you essentially a system that watches and is continually vigilant of what's going on your system for specific applications and transactions that you're watching. It classifies those anomalies, that's ConicIT, and then it kicks off, as Spencer said, Strobe. And so essentially what we've done is we've closed the loop from what happened in production back to development so that they can very quickly understand problems that are happening and fix them. And so finally, just looking at it from the screen's perspective, which is essentially the same thing I showed earlier, we gather information, as I said, from any monitor that you happen to have and happen to be using, gather that information into ConicIT. And I didn't mention, but ConicIT is essentially a system that resides outside of the mainframe. It's on Linux. It can be on Z-Linux. But it's essentially not something that will affect the performance of your system. It uses your existing monitors, and it's very careful about the usage of your monitor. It can then decide to alert. It can decide, if appropriate, to invoke Strobe. That information can then flow back. Here's an example of just putting it into a bug tracking system like Jira, which then goes back into the developers, and they can then fix. And again, that gets deployed into the mainframe. We continue to learn, and so on and so forth. And so essentially, we've built a system that allows, from a DevOps perspective, closing the loop between development and operations. So getting started, as I said, is actually very simple. Right? Because we're an external system, essentially you just need a Z-Linux or you need a Linux box. It looks to the system as if it's just another user of the monitors, so you just connect it as another user to your existing monitors, and it doesn't use any mainframe resources, any mainframe MIPS, and it's very cognizant about using the monitors judiciously so we don't use up too many resources. It's very easy to install. A few hours you've got it installed on your Linux. You've connected it. All you need to do is essentially point and click and show it what are the parameters that you want it to be able to track. It then starts learning your system. You can also tailor it a little bit, so it comes out of the box with ready-made rules that are very good and help in many, many cases. But of course, you can decide either when you're installing it or later on to add some rules of your own about parameters and information that is specific and interesting to your organization and to your applications. It starts automatically to gather information and compute these infinite number of thresholds, and it's ready to go. So there's essentially a closed loop here that's very simple to deploy. Within a day, you can have it up and running, connected into your environment, learning and showing you the graphs, and learning what's needed to be understood about your environment. The benefits of using that is, of course, you have improved performance because you can find problems much easier and much faster. Because we can point you to the subsystems and alert you to what's going on, A, before it happens, and B, to the specific systems that have caused the anomaly. We also reduce the amount of people needed in your war rooms because you only need the people that are from the affected systems, right? You don't need everyone involved trying to figure out whether it's their subsystem that's involved. We actually help you by providing the alert and providing the root cause of what are the systems that are involved that cause the anomaly, and it helps new recruits understand the system even better because they many times don't have the deep expertise to understand what's going on. This provides them a helper system that can help with the deep expertise and the deep dive that's needed to make things work. And it lowers cost, right? The idea is that because you can now provide improved service and you don't need to have all the people involved all the time, it requires less resources to provide the same level of quality than you did before and to ensure the quality. And other folks have actually used the system to help with saving MIPS and behavioral profiling because we find anomalies. We can find anomalies that are going to be able to cause an overage from a usage perspective. And as we all know, those overages are very expensive. And so there are organizations that use ConicIT to help understand and predict that there's going to be an overage and do something about it before they're charged a lot of money by IBM.
Thanks, Jacob. This brings us back to our DevOps infinity loop. And I think if you went back a couple of slides, I believe it was slide 22, it really kind of described this whole infinity loop perfectly, for me anyway. And you saw how ConicIT was alerting, and then Strobe would do the deep dive. And then from Strobe, we're actually integrate. We have the ability to integrate with another one of the tools that you may be using in your organization today, Jira. So we open up the Jira issue, and then someone can grab that, look at it, and then they may need to drill into the code, which is where the Compuware Topaz product comes into play, which brings us over to the dev side. So there's tools out there that you guys are already using today, and we're creating APIs in our products to integrate into those other tools. So Compuware is really trying to help mainstream the mainframe and make it just a part of the entire organization, not trying to separate distributed from the mainframe. And with that, I want to turn it back over to Janet.
Before we get to the Q&A, I'd like to remind everybody to please take a moment to fill out the survey at the end to have a chance of winning that $50 American Express gift card. Your answers definitely help us improve our products and our partnerships with various organizations. And with that, let's start Q&A. Just a reminder to the audience that if we don't get to your question, we definitely will follow up with you after the broadcast should we not be able to answer it. So first question out there is there a cost or license required for this integration?
I believe I can handle that. No, there is no cost or license required. You need to be, obviously, a customer of ConicIT and a customer of Compuware's Strobe product. But once you have the two tools, there is no license required or additional cost required to enable the integration.
Does ConicIT preserve our performance and capacity planning details for the future?
Everything that ConicIT gathers is actually put into a database. So essentially, yes, you can gather this information, you can use it and query it and get information out of it as needed.
Thank you. Does I'm sorry, I'm rereading the same question. What about special days like the 4th of July? How does the system learn about them?
This is Jacob again. It essentially allows you to configure for them. So if they happen during the learning period, it will learn about them. But of course, we all know there's certain dates like the 4th of July that really only happen once a year, and you need to be able to account for them before they've actually happened. And so when configuring the ConicIT system, it allows for the configuration of special dates like the 4th of July or Cinco de Mayo if you happen to be in a different part of the world, so that the system will know to act differently on those days and not just assume it's a normal day.
Thank you. How is this product different better than the IBM tool that runs in its own LPAR?
I'm going to assume that the question is about Z-Aware, because that's a product that I know from IBM. And the answer is it's very different in two ways. Well, the main difference is that Z-Aware is looking at system variables. It's looking at the system. We look at the application, and we look at the application transaction. So it's a very different part of the stack that we're looking at. We solve different problems. The other one is that we've understood that having a monitor that's watching essentially what's going on and trying to find performance problems running on the mainframe itself, in other words, running on the system that you're having performance problems with, is not always the best idea. That's why we found that it made sense to actually have it on an external system, so that if your mainframe is in trouble and it's having issues, you don't want to put any extra load on it. And so the two differences are we look at a different part of the stack, we look at the application, not at the system, and that we run essentially out of band so that we don't put any extra load on the mainframe itself.
Thank you, Jacob. Next question. Do you have to have Topaz for this to work, or just Strobe/iStrobe?
I can handle that one. You just have to have Strobe and iStrobe, and iStrobe is a requirement in the solution because ConicIT is making a call to an API that's exposed through iStrobe. All
right. I think we might have time for one more here. Is there any plan to include this as part of the Strobe suite, I mean as a solution?
I can handle that, and we're not going to include this as part of Strobe. We're integrating with, and ConicIT is integrating with us, with Strobe. So, it's up to you, the customer, if you want both solutions, then you would get both.
Thanks, Spencer. Here's another question. Is Z-Linux supported?
This is Jacob. I'll take that. There could be two questions here. I'll answer both of them. One is, yes, ConicIT can run on Z-Linux, if that is the question, where the system actually runs. The other question may be, do we monitor Z-Linux? And as I said, we're not a system monitor. We don't gather information from your existing monitors. So if you've connected them to your existing monitors, if you have OmegaMon monitoring the application that's going on in the Z-Linux, the answer is yes. Otherwise, the answer is no.
Okay, and I think we have time for one last question. Do you need auto strobe?
I can handle that. No, you do not need auto strobe. So you do just need Strobe and iStrobe for this in order for this to work.
Thank you, Spencer. Thank you, Jacob. This concludes our broadcast. If we were unable to answer your questions, we will reach out to you after the live presentation ends. With that, please enjoy your day.